notes. Okay, this right here is something that kind of you need to memorize. So a graph always, we're going to say, is y equals f of x. So the function is named f. It's just a fancy name for it. It means x is the input, y is the output. So these are all the things that I could do. So you already saw on my quadratic example, I had an a multiplier, I had a c mover, and I had a d mover. I didn't have a b on mine. But you could do all those things. Okay, let's talk about the next page and then we'll go back. Okay, A and D affect the y. An A and a D would change your y's on a graph. And the B's and the C's will do stuff to the x. And when it affects the x, it will do it in the opposite way. So on, for instance, the example that I gave you, did you notice that this had a subtract 4 in it? But what ended up happening? We went right 4. So that's opposite, right? Because I see a subtract 4, but it ended up going right 4. So that was opposite. That's an x, it's opposite. There was a plus 5, and that went up 5. That's normal because it changed the y. So when it's changing something to x, it's doing an opposite of what you see. Okay, so the A, this is how it can change. It can vertically stretch something, it can vertically compress something, or it can reflect something over the x-axis. Those are the things A can do. D can move things up or down. Those are the things that Y can do. So do we want a visual? Okay, there's a visual of something that got vertically stretched. So I drew like a little upside down U, which is kind of almost like an N shape, and then I drew it bigger N. Can you think of like a puppet and how you would kind of pull it apart, or, right? Something like that, you're pulling it apart. So I stretched it. Something that's vertically compressed, so this time I'll draw like a triangle like that. So now think like this, and now I'm going to take it and I'm going to squish it towards the axis. I'm going to squish it towards the axis. So I kind of squished it, I pushed it towards the axis like that. So that's a vertical compression. And a reflection would look like that. Okay, it's reflecting over the x-axis because I'm changing the y's. So these have positive y's and those have negative y's. That's what I was doing. Moving something up or down. That would look kind of like that. You're moving something up and down. Okay, so that's the A and that's the D. So B and C will change the X. So B is going to either compress or stretch it horizontally. So remember, it's the opposite. So if you see the number 5, it actually squishes it in by 5. If you see the number 1/2, it actually makes it go out by 2. Does that make sense in math? If you divide something by 1/3, what does it actually do? Multiplies by 3. So everything is going to be opposite here. Okay, so if I take a graph like this, this is what a horizontal compression could look like. So I'm like an accordion. You guys know what an accordion instrument is? You go in and out like this. You're always squishing it towards the axis. So then a horizontal stretch would be just pulling it out again. Compress it, stretch it. Did you notice how I compress it if B is bigger than 1, opposite, and I stretch it if B is less than 1? Your brain has to think opposite. If you see a big number, you make it smaller. If you see a small number, you actually make it bigger. And if you want to reflect, so if I take a shape like that and reflect it, I would reflect it over the y-axis. So from a positive x to a negative x, you're flipping it over the y-axis. So when something changes x, it goes over the y-axis. And then this is a horizontal translation for C. So you can be moving things left and right. That's how that would move. And it's opposite. So do you see how I listed here? If you see a plus, you actually move something left. If you see a subtract, you actually move something right. Okay. Here's something that is your golden ticket in this box. This is everything. Okay, so A and D affect your Y. A is a multiplier and D is an adder. So you're going to multiply Y and add. And bed mass would happen there. You would multiply and then add. B and C affect X in an opposite way. So if this shows times B, what's doing the opposite? Divide by B. And if this shows plus C, I've got to do the opposite. So I have to minus C. This is a lot to take in, right? This is why I put this page all together. It's a summary of what's happening. Okay, so let's break things down. So let's talk about A, just A. We're going to break it down one at a time. Okay, so A, it affects our Y. And do you remember what we do with an A? We times Y. Whoops, I should just put an A here. I might have a different A. We times the Y. So that's what A does. It changes your Y. So this first one, all my points have to be changed by doing 2y. So what happens to 0, 0? It becomes 0, comma, what's 2 times 0?
0.
Doesn't move. What happens to the coordinate 1, comma 1?
It's 1, 2.
Becomes 1, comma 2. The next coordinate here is 2, comma 4. What would it become?
2, 8.
2, comma 8. So in words, it vertical stretch. It stretched it. The vertical stretch. Okay, if that number in front is bigger than 1, it will stretch it. Okay, the next I have an a value of 1/2. So x comma 1/2 y. So I'm going to take the coordinates. So where does 0, 0 change to? It doesn't. Where does 1, comma 1 change to? 1, comma 1/2. 2, comma 4 would become 2, comma, what's 1/2 of 4? 2. So what did I do physically? I took it and I went like this. See what I'm doing? I took it and I pushed it like this, like stomping on a can. I vertically compressed it. I vertically compressed it by 2. Okay, next. This time our a is -1. So x comma -y. So 0, 0 would become 0, comma, well, -0, that's not really a thing. So 0, 0. 1, comma 1 would become 1, comma -1. Do you see what's happening? So that would be the new shape. So that is called the reflection. It reflects over
X.
the x-axis. You could also call it a vertical reflection. That would be good as well. If you like that, vertical reflection. I often just get almost everybody, they just think this one reflects over a certain axis. Okay, B. So when you do a B, you're going to have to change x. And it's an opposite thinking. When you change anything with an x, it's opposite. So here, it looks like I'm timesing by 2. So what's the opposite I'm going to do? Divide by 2. Okay, so 0, 0, it stays. What happens when you put 1, 1 into this? It would become 1/2, comma 1. And then the next would be 2, comma 4. So what's 2 divided by 2? Becomes 1, comma 4. Okay, that's an accordion move. You playing an accordion, you squished it. You squished it in. An accordion, you squished it in. So that's called a horizontal compression. Okay? Remember, it's opposite. So physically, when I looked, there was a times by 2. It actually compressed things by 2. Okay. Now, this one is a half. So what happens? This is what it would be like. X divided by 1/2. So then I have to think, what's the same mathematical move as dividing by 1/2? Timesing by 2. Okay? So again, everything is opposite. So 1, 1 will turn into 2, 1. And 2, 4 will change to 2 times 2. So 4, 4. So what physically happened? An X is like playing an accordion. So that did a horizontal stretch. And again, your brain's working opposite. Yeah, you see a times by 1/2. Look at the words. It's stretching something. Okay, your brain has to think opposite of what you want. Okay, and X divided by -1. Okay, so just negating your X. So 1, 1 will become -1, 1. 2, 4 will go to -2, 4. So that's that reflection. It flip-flopped over. So reflects over the y-axis. And you can also use the words horizontal reflection. Okay, so now we're going to go to the C. So a C is on the X part, so we're thinking opposite. Opposite, opposite. So X minus C is how it changes. Okay, so here it's going to change X, so X plus 1. That's what's going to happen. The Y will stay the same, it will just change X. So 0, 0 will become 1, 0. 1, 1 will become 2, 1. 2, 4 will become 3, 4. So therefore my graph moved right 1. I think I should write this down because you might just run into this language. That could be called a horizontal translation or a shift. You might see some of those words. So let's write it once so you can understand when you read it. I'm okay if you just write me, it went right 1. I'm okay, you don't have to write fancy. It horizontally translated 1 to the right. I'm okay without that, that's fine. But you need to recognize that it might be written in your book. Okay, so what happens here? This should go left. I'm going to write that already. Left by 2. opposite. Left 2. So I'm going to take the points and I'm just going to physically pick them off the paper. Just going to move them left. Okay, now do you see that this is a D? Are you understanding how I'm recognizing it's a D? Because it's after the bracket. It's not. So a C is in the bracket, a D is out of the bracket. So this one will affect Y, so X comma Y plus D. So this is not opposite. It would be whatever I see is what I do. All right. So this one would look like this. X comma Y plus 2. So all the Y's, you're going to add 2 to the Y. So 0, 0, 0, 2. 1, 1 would become 1 comma 3. So it's going to move up 2. The fancy name would be a vertical shift up 2 units. A vertical translation up 2 units. That would be the fancier name that you might see. Okay, can you just finish the last one on your own? What's going to happen here? Nothing to X, and it's going to go Y subtract 1. So physically, I'm going to write this. It should be moving down 1. And then I'm just going to give a little quick sketch here. Okay, how does that seem? Like overload? Okay, let's talk about some of these. Okay, so do you understand bed mass would mean you have to multiply, divide before you add or subtract? So if that's the case, you would have to do any reflection or compression or a stretch before a shift, up or down. Does that make sense? You'd have to do it in that order. So here's my example. So if this was my original equation, there was a 3 and a 2. Could you tell me what letters this and this are? An A, a B, or a C, or a D? 3 is a what letter? An A. And 2 is a D. So you know what I did? I vertically stretched by 3. Then I did a vertical shift of 2. I went up 2. Okay, does that make sense? Okay, let's talk about this then. Okay, 4 is what? You need to give it a letter. A, B, C, D. A and a D. So what happened? We did a vertical stretch by 4, followed by a up 3. Vertical stretch and then up. Okay, next one. 4 is a what letter? It's a B, and then this is a C. So we're changing X stuff. X stuff is getting changed. So opposite brain. Opposite brain. So when you see this, it looks like a multiplier by 4. So what's going to happen oppositely? You're going to do a horizontal compression. by 4. Your accordion, you're going to squish it in 4 times. And then you're going to move which direction to? Right 2. Okay, we have a 1/5. Which letter? That's an A letter. And 3, that's a C. So A is a small number. So what happens if you vertically get smaller? We're going to say we're going to vertically compress by 5. If you're going to do something 1/5, it's compressing 5 times. And then which direction is the 3? It's an X move, so either left or right. Gotta go opposite. So left 3. Okay, next one we have an A, we have a B, and a D. So A, that changes the Y. So if you change the Y by 2, it's a vertical stretch by 2. B, that's on an X. So if you change the X by 3, oh, we got to do opposite. So changing the X is a horizontal. Opposite would be compress by 3. And D, whatever you see is what you do. Down 8. Okay, the next one I need you to put a star beside it. This one will be on your test. Something is wrong with this. Can you look at your original? This is what it needs to look like. This is the format we follow. What's wrong with the format I gave you?
The 3 needs to be outside of a bracket.
Factored out. You got it. It's not looking how it's supposed to. If you have a B value, you have to have it factored out. So I'm going to take that 3 out of the bracket part, and then it leaves me with X minus 2. Okay, do you see what I did there with the 6?
Why are the brackets squared, out of curiosity?
Easier to look at to format it.
All right.
Did you just put 2 sets of round brackets?
No, I just wanted to know.
Okay, this is a B and this is a C. So I do get this lots on the test. I get a lot of people that tell me write 6. Nope, that's not how it goes. Okay, so now my final answer would be horizontal compress by 3 and right 2. Okay, last one. We have a -1 in the front. So that's an A. This is a B. And this is a D. Okay, negatives cause reflections. Which way does this go though? Reflect over what axis? So it's an A, it changes your Y. So if you are changing your Y's, you're going from this way to this way. So it's flipping over the x-axis. If you wrote vertical reflection, same. Okay. B is 1/3. We have to put opposite brain hat on. What's the same math as dividing by 1/3? Multiplying by 3. So if you multiply your x by 3, it horizontally stretches by 3. That's what it'll physically do. Opposite brain. And then this is a D, so we have the same brain hat on, so up 2. Okay, maybe I'll do like one more question and then I'll let you try some on your own because I don't want to like overkill your brain here. Okay, so we wrote an equation before. All right, so here's the last question so you can get to work. Do you remember what we did? X would get divided by B, opposite, and it would get a minus C. Do you remember what the Y's were all about? We would times by A, and then we would add D. Okay? So Y has a multiplier, X has a divider. Y has an adder, X has a subtractor, right? Opposite. Okay, so let's write this out. If this is an A and this is a C, can you apply those into something that looks like this? So X plus 4. See where I got that from? I did an opposite. Comma 2y, because that's a multiplier. So if we were starting at 12, negative 8, where would we end up? So what is 12 plus 4? 16, comma, negative 16. That's the new point. All right, 2 more questions. Then we can do some jumping jacks maybe before we start some math. Okay, give me 2 letters here, A, B, C, D. B and a D. Okay, so B is a divider. So X divided by 4. D adds to the Y, so Y plus 5. So what is my new coordinate? So 12 divided by 4 makes a 3. Negative 8, I'd have to add 5. So 3, negative 3. Okay, the last one I gave you here has an A, B, C, and a D. Can you put them all in there? So an A, it has a B, it has a C, and a D. Okay, ready? X gets divided by 3. Then I do opposite, so minus 2. A gets timesing the Y, subtract 1. Okay. Now, can you fill out? So I'm going to put a 12 in there, and I'm going to put a negative 8 in there. Without your calculator, what are we going to get? Ty is putting his calculator away. We can do it. 12 divided by 3 is 4 minus 2, 2. What is 4 times negative 8? Negative 32. And then if you went one colder, negative 33. Okay, I'm gonna stop there.